All right, hey guys, it's Tuesday and I'm gone today because my daughter is sick, but she's doing a lot better and I should be back tomorrow. So thank you so much for understanding. I really appreciate you guys understanding why I'm gone. Anyway, but we're going to move on to percent yield because this is actually a lab we're going to do on Thursday and Friday. So percent yield is all it is. It's a comparison to how much product you make in a lab, called the actual yield, versus how much you should make in the lab, called the theoretical yield, and then times 100 to get it to a percent. Right. Now, the fun thing about this and the actual easy thing about this is the actual yield is always given to you, or it's something that you find in the lab. That's what you actually do in the lab. And the theoretical yield is the part where we've been doing for the last week. This is all we've been doing are theoretical yields because we haven't actually done anything. It's called a theoretical. So let me show you how to do one of these problems. Number one, let's look at this. So we have 50 grams of silicon dioxide, that's one of the reactants, and it's heated with excess carbon, which is right here. Well, that excess word is great because then it tells us we don't have to do a limiting reagent problem. We know that the 50 grams of silicon dioxide is what's limiting us, so we only have to run through one of these things. So, and then what is this part over here? 32.2 grams of silicon carbide is produced. Oh, okay, so it's telling us how much product it is, so that must be the actual yield. So that's going to go in right up here. So if we even do, I'm going to go ahead and erase my line here so I give you kind of an idea here what we're doing. We already know that the top half of this percent yield is going to be 32.2, so let's go ahead and just fill that in. Now what we need to do is find the theoretical yield. How much of this silicon carbide was supposed to be made? And how do we do that? Well, we do one of the problems we've been doing for the last week. We start with how much reactant we have, which is 50 grams of silicon dioxide. And we are going to try to find how many grams of silicon carbide is made by that. So we go through the exact same thing we have been doing. We're going to go ahead and divide by the molar mass of silicon dioxide. So go ahead and pause it now and get your stuff and figure out the molar mass of silicon dioxide. All right. Got that yet? Oxygen is 2 of them at 32, and silicon is, what is silicon? 28.09. So we have 28.09 plus a 32. So you should have gotten 60.09 grams. And that's 1 mole of silicon dioxide. What's our recipe step? We've got 1 for every 1 mole of silicon dioxide. It makes 1 mole of silicon carbide. So that makes it easy. And what's our last step? Our last step is to multiply by the molar mass so we can figure out how many grams of silicon carbide are made. And so you need to figure out the molar mass of silicon carbide. So go ahead and do that, please. And you should have gotten something like 40.1 grams. All right, so this is a pretty simple problem on the math. Everything's rather simplified for us. So just go ahead and you're going to do 50 times 40.1 and then divide that by 60.09. And you should get something like 33.4 grams of silicon carbide. And this was what's predicted. That's what's supposed to come out of the reaction. But what actually came out of the reaction? Well, the problem said it's only 32.2. So now we're going to take our theoretical that we just found, and we're going to put that up here into our percent yield equation. So it's 32.2 divided by 33.4 times 100, and you should get something like 96.4%, which is actually a pretty good yield. In some chemical reactions it gets down to, oh geez, it's like 12%, 8%, which in cases like that you really have to make sure that your reactants aren't that expensive because otherwise you're just not making much product. But so we find that 96.4% of this reaction was completed. Hopefully on our lab on, we're going to be on the lab on Thursday and Friday, that we get that good of yield. Okay, so I'm actually going to go ahead and do number 2 and then the bottom of this page in class on Wednesday with you guys. So what I'd like for you to do right now is go ahead and do problems 2, 4, and 6. You should have already done 1, 3, and 5 for today. And remember, the key is on the back of the door. So you can check those. So 1, 3, and 5, make sure those are correct, because then those are going to help you do number 2, 4, and 6. So check the key on the back of the door, make sure 1, 3, and 5 are correct, and then do 2, 4, and 6. If you'd like to go ahead and try out number 2 and the bottom of the page, go ahead and do that. But we're going to go over that on Wednesday. So go ahead and work on this, and I hope you guys have a really great day.